Today's lesson will be a quick review of fractions and our exponent laws before we move into converting between radical form and rational exponent form. So to review fractions, we're going to go ahead and look at how to add and subtract them first. For both adding and subtracting, they must have a common denominator. So I'm going to go ahead and write that for both. Common denominator. And then I'm going to go ahead and do that in each of these examples. So I'm going to zoom in. So for 9 and 6, I can create a common denominator of 18. That's going to be the smallest common denominator. So I'm going to multiply the first fraction by 2 on the top and the bottom. And then I'm going to multiply the second fraction by 3 on the top and the bottom. That's going to give me 18 in my denominator for both of them. So that gives me 2 over 18 plus 3 over 18 for a total of 5 over 18. Remember, we only add the numerators. Same thing when we subtract, we need to get common denominators. So my common denominator of 4 and 3 is going to be 12. So I'm going to multiply by 3 on the top and bottom for the first fraction, and by 4 on the top and bottom for the second. So that's going to give me 3 over 12 minus 8 over 12, which is going to give me negative 5 over 12. You can also put the negative out front if you prefer, so it's negative and then your fraction 5 over 12. For multiplication, we need to multiply across the top and then across the bottom. And then for division, we are going to keep, change, flip. So keep the first fraction, change the sign, flip the second fraction, and then it becomes a multiplication problem. So let's look at those. So typically what I try to start with is I try to simplify if I can, and you simplify diagonally. 2 and 5 can't simplify, and there's not another x, but 3 and 6 both simplify. They'd both divide by 3. So I'm going to divide them both by 3 just to go ahead and have it as simplified as possible when I'm starting. So I'm going to multiply across the top. 2 times 2 gives me 4. X times y gives me xy. And then on the bottom, 1 times 5 gives me 5. Now, if you didn't simplify to start with, you would get a bigger answer and then would need to simplify. For division, this 3 is going to be 3 over 1. We're going to need that for when we flip our fraction. So we are going to keep the first fraction. We are going to change the sign of the fraction and then flip the second one. And now this is a multiplication problem, so we can multiply straight across. 2 times 1 gives me 2. 5 times 3 gives me 15. All right, for my laws of exponents, when we have the same base, so in this example, x is our base. When we have the same base, what we're going to do is add the exponents. Sorry, that looks a little weird, but it's okay. All right, so I'm going to come over here. I've got my base is x, and I'm going to add 2 plus 2/3. Now we don't want a mixed number, so I'm going to make that, that 2 I'm going to think of as 6 over 3, so they have the same denominator. So it's going to give me x to the 8/3, because 6 plus 2 gives me 8. Now when we divide, it's the opposite. We're going to subtract the exponents. So again, we've got the same base of 2. So this is going to be 2 to the 1/2 minus 1/3. So if I made those common denominators, I would have a common denominator of 6. So 3/6 minus 2/6 gives me 1/6, which would be my final answer. All right, for the power rule, you are raising an exponent to another exponent. You are going to multiply the exponents. I'm just going to abbreviate exponents here. So you're going to do that for the numerator and the denominator. So I'm going to do x squared times 3 over y to the 5th times 3. So that gives me x to the 6th over y to the 15th. For negative exponents, you flip the base. And remove the negative sign. So we can simplify this here. This becomes 2 to the 1/3 minus 1/2, which becomes 2 to the negative 1/6. So what I'm going to do is I'm going to make this 2 is 2 over 1. So I'm going to flip the base. So it's 1/2. Sorry, that looks really weird. Let's go back and try that again. So 1/2. And then I'm going to make my exponent positive, so 1/6. For parentheses, we're going to work from the inside out. So I like to simplify whatever's inside. I usually start with the numbers, see if I can simplify them. 6 over 9. I know I can divide those by 3, so this becomes 2, and this becomes 3. Then I'm going to combine my x's by adding them because they're being multiplied. And then I'm going to subtract the exponents from my y's because they're being divided. So that's going to end up going like this. We're going to have 2 over 3 x squared plus x times x to the 5th is x to the 7th, and y cubed divided by y is y squared. So that is now being raised to the 4th power. So that means everything inside is going to go to the 4th power. The 2, the x to the 7th, the y squared, and the denominator, the 3. So we're going to end up with 16 x to the 28, y to the 8 over 81. And then our last rule, anything raised to the 0 is 1. So we could simplify all of this in the middle right here, which we already have. We know it's 2x to the 7th y squared over 3. But as soon as we raise it to the 0 power, it just becomes 1. All right, so once again, just to review these, when you multiply like bases, you are adding exponents. When you divide them with like bases, you will subtract exponents. Raising to a power means you multiply exponents. Anything to the power of 0 is 1. A negative exponent means that you flip the base. And make it positive. And then an exponent outside of a set of parentheses means you work inside out. Work from the inside out. All right, we're going to use these rules as we learn how to convert between radical form and rational exponent, which is also, so rational means we're looking at fraction exponents. All right, so this one right here's got a radical sign. This is our radical form. And then this right here has a fraction. This is our rational exponent form. And here's how we're going to go between them. So with a radical, we have something on the outside. Normally with the square root, we don't write the 2, but it's because it's understood, but we can also have cubed root, fourth root, fifth root, etc. So that value, that's my b value. And then inside, sometimes we'll have an exponent. We're going to call that our a value. When we convert this to a fraction, what is inside is going to become our numerator. And what is outside is going to become our denominator. So inside up, outside down. So let's look at a couple of examples here. We're going to rewrite it in the opposite form. So this right here is our rational exponent. So we want to write this as a radical. So I'm going to take, I know I'm going to have a radical sign, and my base is x. I'm going to take this 2, and it's going to go inside. This 5 is going to go outside. Of course, I did this with the opposite colors of above. I'm sorry. Just know that the colors go together. All right. For the next one, I'm going to go ahead and do my radical sign because this is a rational exponent. I'm going to go ahead and put my base of a. I'm going to take the 7, which is my numerator, put it inside. The 4, which is my denominator, I'm going to put it outside. Now I could simplify this. For now, I'm just going to leave it as is. But if I were to simplify it, it would be, we would have a on the outside, and then a to the 3rd on the inside. All right, for C and D, we have radicals. We want to go to exponents, or to rational exponent. So I'm going to put my base, which in this case is z. And I know that my inside number becomes my numerator. My outside number becomes my denominator. And my last one, I'm going to have C as my base. This -5 is going to be my numerator. This 3 is going to be my denominator. So that is technically in rational exponent form. However, we don't like having negative exponents. So we are going to flip the base. So this becomes 1 over c and make my exponents positive 5/3. All right, with these, we're going to evaluate, which means we're going to find a number as our final answer. So I'm going to take my radical, I'm going to put 25 on the inside as my base. Then 3 becomes my exponent inside. 2 becomes my number outside. Now, 2 means the square root, so sometimes we don't always write it like that. We don't always write the 2. You don't have to. But another way to write this, you can also write the radical with the exponent on the outside, because in this case, we know what the square root of 25 is. That's one of our easy ones. That's a 5. and then I can take that to the power of 3, which will give me 125. So I'm going to use this method here because I can see that I've got a 2 that's going to go on the outside here. Whoops, I forgot my last parentheses. And a 3 that will go right here. And 27 is a perfect cube. So the cube of 27 is 3, so I'm going to write that. And then when I do 3 squared, it gives me 9. All right, this one, it's very important to remember that the negative is on the outside. So I'm going to keep the negative outside of everything. I'm going to take the 3, put that here. The 2 goes here. Again, that 2 is usually an understood, so this is now negative. And then the square root of 16 is 4. And cubed. And then 4 cubed is 64. And that negative stays on the outside. If it had been inside the parentheses, we would use it, although with it being cubed, it would stay negative. But we would do our exponents before we would do our multiplication. All right, the next one. This one I'm going to do a little bit differently. I'm actually going to do this the original way, so I actually don't need that. So I've got negative 64 as my base. I'm going to put the 2 inside, the 3 outside. So I'm going to do negative 64, so the negative is included, and I'm going to square it. So a negative times a negative is going to give me a positive, and 64 times 64 gives me, well, that's not what I wanted. Gives me 4,096. And when I find the cubed root of that, I get 16. You can technically find the cube root of a negative number, but we have not learned that yet, so I'm not gonna show you that way just yet. And E, we've got a negative exponent, so I'm going to first rewrite this. I'm going to flip the fraction, flip the base, so it's now 25 over 64, and I'm going to make the exponent positive, so 3/2. So now when I write this, I'm going to do my giant radical. The 3 is going to come inside. I should have written the other first, but that's okay. The 2 is going to come outside. Let me go ahead and write my fraction. And actually, I am going to leave this 3 on the outside. So I'm going to do parentheses, and I'm going to put the 3 on the outside because I'm going to be able to find 25 and 64 are both perfect squares. So I know I'm going to be able to find the square root of them. So essentially, I'm breaking this apart. Square root of 25 over the square root of 64. Square root of 25 is 5. Square root of 64 is 8. And then when I cube those, I get 125 over 512. Right, the last page is just some examples. So I'm going to do technically the odds, but I'll have the answer key for you for the evens. And by odds, I mean A and C, and then you'll have B and D available in the answer key. All right, so for 3, we want to write using fractional exponents. So I'm going to take my base, which is A. I'm going to take the inside number and make that my numerator. This is an understood 2, so I'm going to write that as the 2. And then this is actually a power on the outside. So now I've got the power rule, which tells me I am going to multiply those. So 5 halves times 3 gives me 15 halves. And I'm just going to leave it like that because otherwise, to simplify it, I would have to put it back into radical form, and I don't want to do that. I want to leave it as a fractional exponent. All right, I'm going to let you try B by yourself. I would say, remember to break apart the radical. So that you can have the number as one radical times the radical with the variables. Makes things a little bit easier. All right, for 4, we're going the other way. We've got our fraction, we're going backwards. So I'm going to have a radical sign. I'm going to have an x. I'm going to take the top number and put it inside, the bottom number, take it outside. Now here's something with these. When we've got a fraction like this, I find that the easiest way to simplify them is to take this fraction and make it a mixed number. So it's 2 2/3, because this 2, the whole number 2, is going to be my exponent on the outside. So this is going to be x squared. And this 2 is going to be my exponent inside. So this is x squared times the cubed root of x squared. That is the most simplified version. All right, 2 more. So this one says simplify the following, write the solutions using a fractional exponent and radical form. So I'm going to do both. I'm going to start off with the fractional exponent for, I believe, the majority of them. So here we're multiplying with the same base, so I need to have the same denominator. So common denominator is going to be 12. So I'm going to do 10/12 times 3/12. And now that I have a common denominator, I'm going to add them. So 10 plus 3 gives me 13/12. So that is my fractional. Now to move this to radical form, remember my numerator goes inside, denominator goes here. And then just as I told you above, we can take that 13/12, make it a mixed number, so 1 1/12. And that's going to help me simplify. So there's going to be a y to the first on the outside, which we don't usually write the exponent if it's 1. And then the 12th root of y, which again has a 1 as the exponent from here. All right, I'm going to do C with you as well. So this one we need to convert to fractions. So I'm going to just take each piece and convert it. H is my base. This 2 becomes my numerator. The 6 becomes my denominator. Then I'm going to do the same thing here. H, it's an understood 1, so the 1 becomes my numerator. The 3 becomes my denominator. Now I'm trying to multiply these, so they need to have common denominator so I can add the fractions. So 2 over 6 luckily reduces, so I'm going to go ahead and reduce that to 1 over 3. And since they have the same base, I'm just going to add them. 1/3 plus 1/3 is 2/3. And then this one's nice and easy to go to radical form. I'm going to do my radical, my base, my numerator goes inside, my denominator goes outside. And that's it. So for the other ones, look for the key. And if you have any questions, please email me and I will help you out as best I can.